Assalamualaikum and good day everyone. Before we start, I want to show you something. This is the complete guide of trigonometric derivatives. At first glance, it might look scary and long, but let me be very clear. You do not need to memorize this. You do not need to remember every formula here. I'm only showing this to prove one thing, which is trigonometric derivatives are organized and not random. Once you understand the structure, you will not feel overwhelmed anymore. This is the table you will actually use, and this table will be in your notes and you will refer to it while doing exercises. So our goal is not memorization. Our goal is to identify the function, find the correct row in the table, and apply it carefully. Let's start with the basic trigonometric function, which is these 6 functions. When you see one of these functions, you simply match it to the correct rows. That's it. For example, when you see sine x, its derivative will be cos x. When you see cos x, its derivative will be negative sin x, and so on, so forth. Now look carefully at this area. You will notice something consistent. First of all, they has the same arrangement as the basic trigonometric function, which is starting from sine to cosecant, right? Sine to cosecant. And the difference is actually on the k. For this one, it is called a k times x version, right? Which is, we have some multiplier. So basically for this case, every time the angle is k times x, the derivative is multiplied by k. Right? This applied to all version of derivative. All version of trigonometric function. So again, every time the angle has k times x, like this, its derivative remain the same as the basic trigonometric derivative, but it adds a bit on the k multiplication. So k times x, its derivative is k times the derivative. So basically the rule is very simple. If the inside is kx, then multiply the whole derivative by k. Next, for hyperbolic function, the table is very straightforward. Right? If it is sine hx, the derivative is cos hx. The same goes for if it is cos hx, it will be the other way around, which is it becomes sine sh. No negative sign, no extra steps. Now we come to the part that might confuse students, which is this. This is trigonometric functions with power, right? Like we have sine to the power of nx, and then cos to the power of nx, and also tan to the power of nx. And as you can see, its derivative is actually quite, if you look at the first glance, it is quite complicated, but it's actually not, because without remembering this derivative, right, we can actually work it out, find what is this by using some simple derivative from power rule and also from chain rule. With that being said, now let's see how this trigonometric with power get its derivative. So basically, for example, let's look at this sine to the power of nx. So its derivative is being obtained by using the basic rule in derivative. So let's say for sine nx, we can change this to sine x to the power of n. So from this we know that we are dealing with two function, which is sine x itself and also its power. So we kind of having an inner function, which is the inside function, and the outer function, which is the function outside. So let's split it up. So we have 1 and 2. Okay, so basically the first one is, let's take the outer first. We have, okay, the power of n, and then we have the inner function, which is sine x. So basically what we want to do is we want to differentiate these two. So we want to differentiate the power and also the sine x. So let's differentiate it. So differentiating power rule using is the power rule formula, which is we are going to obtain n. Alright, just ignore what's inside. So n to the power of n minus 1. And for sine x, we are going to get cos x. Okay, so now that we have differentiated the two, we can then combine it again, right, to get its final derivative. So the d over dx for sine to the power of nx is, we can just write n, and then inside the bracket is sine x, right? Its original function that you want to differentiate, n minus 1, times with cos x. So this can be your final function, or if you want to be a bit more proper, we can rewrite it back in the way that it being shown first. So basically we were to write n times with sine n minus 1 x times with cos x. So this is the derivative of sine to the power of n x. And if you look at this, it's actually showing the same thing. So this is what I want to show you regarding the power form of trigonometric function, which is you can try to be familiar with it, remember it, or the other way around, if you familiar with power rule and chain rule, you can also deal with it. So I have shown you how to find the derivative for sine to the power of n x. So the same goes for cos to the power of n and tan to the power of n, right? Exactly the same thing. So you can actually figure it out without remembering or familiar yourself with this derivative. Now let's apply on what we have learned, right, for trigonometric derivative. Let's try to do example 4.2. Let us do question B first. Okay, so basically, as you can see here, for this question, you have 1, 2, and 3 terms. So basically, let's try to solve this one. So let's to make it more structure, let's split it into 3 parts. So the first one we need to differentiate right? So we have to differentiate dy over dx to sine 5x, and the second one is dy over dx of 3 cotangent 2x, and the third one is dy over dx cos 5 3x. So let's differentiate one by one. So we know that for the first one we have a constant, so let's pull out that constant. So basically we will ignore 2, so dy over dx, so let leave us with sine 5x, which later on will be actually differentiate using the kx formula, kx rule. So for the second one also we have a constant, let's put it out, cotangent 2x. And then for the last one, we don't have constant, but we can actually rewrite it so that it looks less intimidating. So instead of cos to the power of 5 3x, we can write cos 3x to the power of 5. So now that we have do all of the cosmetic, so we can next differentiate it. So the differentiation of sine 5x is we have first, don't forget the constant, 2 times 5 cos 5x. Alright, so basically this will be 10 cos 5x. And next we have the cotangent. So 3, which is the constant, times with, we got k here 2, so 2 cotangent is equal to negative cosecant squared x. So 2 negative times negative cosecant squared x, or for this case 2x, right, squared 2x. So if you try to tidy it up a bit, we get negative 6 cosecant squared 2x. So next, for this one, we actually have two functions, which is the first one is the outer function, which is, so we are going to differentiate the power 5, and then we are also going to differentiate for the inner function, which is cos 3x. So for this, the power is 5, and then the integral function, and 5 minus 1 is 4, and for this one we get negative 3 sine 3x. So if we try to tidy this part up a bit, this is what we get. We get 5 cos 3x to the power of 4 times with negative 3 sine 3x. So actually it is negative 15. Right, I just put sine in front, sine 3x times with cos x to the power of 4, or we can rewrite it as cos to the power of 4 3x. So that is the differentiation of cos 3x to the power of 5. Now that we have all of this derivative, we can just combine them, right, into one piece. So we have, before we proceed with that, let's be clear on this. So basically this is actually positive sum and sum, so we don't have problem to converting it to negative or so on, so just write it down. So we have, for this case, dy over dx is actually equal to 10 cos 5x plus, or for now it become negative, minus 6 cosecant squared 2x minus 15 sin 3x cos 3x. So this is how you actually differentiate the equation of b in our example, right? And it's how you get the answer. Next, let's go back to question A. So for this question, we have, as you can see, 3 terms. So let's split it into 3. So we have the first one, right? We're going to differentiate the dx of 1, and then we need to differentiate of cos to the power of 3x, and next we need to differentiate the negative tan x over 4. Okay, so let us differentiate one by one. So we have differentiate of constant, so 0, and then differentiate this, try go with power. So basically let's rewrite it a bit. So we have d dx with cos x to the power of 3. So for this one, to differentiate it, we will need to split it into 2 parts, which is the outer part, right? We have the power 3, and the inner part, which is the cos. So the derivative of this one is 3 times with the trigo to the power of 3 minus 1, which is 2. And then the derivative of cos x is negative sin x. So combining these two, we get 3 cos x to the power of 2 times with negative sin x. So basically it gives us negative 3 sin x cos squared x. Okay, so for the last one, negative tan x over 4. So firstly, notice that we have constant here, which is it is actually combining with the trigo. So if you look at it at first, you will might not realize it, but it's actually negative 1 over 4. So we split it with our trigo. So now we have d over dx tan x, which is a bit more simple. So let's differentiate it. So let's just carry down negative 1 over 4 times with the derivative of tan x, which is secant squared x. Right, so basically this derivative gives you negative secant squared x over 4. So I think we have differentiate all of the terms that we need to. So the next part is to combine everything. So the first one is 0, so basically we don't need to do anything, but just to show you that we combine everything. So basically the first term is 0, so it is 0, and then we have minus 3 sine x cos squared x minus with secant squared x over 4, and of course this is actually 0, so no need to input it. So this is actually the final answer for example A. So that's it for our discussion for trigonometric function. So in the next video we are going to discuss more on a bit on trigonometric function, and also talk about other functions that actually consists of logarithmic and exponential function. Okay, thank you and assalamualaikum.